Welcome, everyone. Thank you for coming to the session, ManaTEE, Enabling Verifiable AI Transparency with Confidential Computing. Thank you very much for the Linux Foundation for accepting the submission. My name is Mateus Guzzo, and I am a community and developer advocate for TikTok. My focus is in open source privacy-enhancing technologies at TikTok. So let's start with the summary of this talk. If you need to run for another session, you can get a quick snapshot. We're going to look into how to enable AI models, LLMs, evaluations using confidential computing. We're going to be using the LLM evaluation harness, which is an open source, on an open source AI model. Before that, we're going to have a quick introduction to ManaTEE, an open source secure framework for multi-party data collaboration, which is open source project under the Linux Foundation. And before that, we're going to have a quick overview of the technology and the private analytics landscape, focusing on how trust is key in the upcoming, impending AI era. Who is this talk for? Privacy experts and enthusiasts with an interest in getting to know more about confidential computing and AI, open source and transparency advocates looking for an open technical solution to advance verifiable models, and technical and non-technical personnel trying to take a break from Kubernetes sessions. That joke worked better than I expected, which is good. Who am I? So my name is Mateus Guzzo. As I said, I'm based in London. I'm originally from Brazil. My research focus is in the intersection of privacy, open technology, and platform and AI governance. And on my free time, I like to DJ, so maybe next time OSS Europe can invite me on that capacity as well. And this is a photo of me in Amsterdam in 2015, so it's really nice to be back in this wonderful city. Quick disclaimer, this talk is from a non-technical advocate, as you say, so unfortunately I won't be able to give back your money. But there are good news and bad news. So the good news is that you're not in Burning Man right now, which is facing thunderstorms and dust winds of 50 miles an hour. And the weather forecast for the next days is rain. And you've been waiting online for 15 hours to go for this festival in a week. That's a good news. And the other good news is that through interdisciplinarity, there's a lot of different projects and knowledge here, so I'll give you a high-level talk. The bad news is that I might not be able to follow up on many of the questions here in the session, but I would love to follow up after with you, together with my team. So the contents of the talk: confidential computing, some of you already know, private data analytics and model evaluation, ManaTEE framework, a tutorial and demo, and the future of the project going forward, and if there's time, some Q&A. So protecting data throughout its life cycle, we know that there are protections for data at rest. The encrypted file system or the database encryption is an example of that. Here the example is the bear hibernating. It's protected but not really in use. The other data is the data in transit. There are various protections there, network layer protections such as HTTPS, SSL. I think about the bank vehicle transporting value throughout the city. It's protected while it's in transit. But there's a really big question here, which is how to protect data in use. And that's what we're going to talk about today. And also the code in use, which I think is an interesting aspect for the model evaluation. So when we talk about protecting data in use, there's several aspects of vulnerability of data. Users interact with web services which have data storages, and those web services can the data there can be there can be attacks, and that can propagate to the data storage, into the analytics, propagating throughout the system. There can also be employees which are not authorized to see the data or are misusing the data. Users can also act maliciously, and also external services. I'm sure you know of many cases of external services where data has been compromised or there are also vulnerabilities there. And I hope you notice how I chose this classy gangster figure to represent a malicious analyst instead of going with the traditional I'm just a civilian starter pack from Marvel. That joke didn't work as well as I expected. But protecting data in use, this is more or less the design of a physical machine. Your app is connected has the data inside the memory. But other apps and operating systems and parts of this component can access your data as well, and these are non-authorized access that we don't want. And also, this data is operated by personnel in the company or project or organization that you're part of. So how do we protect this data? Well, one solution would be to encrypt the data, which would not allow these malicious actors to access the data. However, cryptography has limitations, right? So first of all, performance aspects. There's large computational overhead, large, not feasible for applications like machine learning. It's almost asking your cousin for a headshot to come to this conference on Sunday, and your cousin shows up with this camera to take the headshot. So it would likely take more than a month to process the results, and it will look good, but it will take a long time, so it's not up for the performance requirements. And also the portability aspect of that, translating an arbitrary program into cryptographic scheme is very, very hard. Imagine you design this crossword and it's all in English, but somebody comes and says, actually, it's not for English, it is for German. So you have to redesign the entire thing, and that's very hard as well. So confidential computing appears as a technology that solves that issue. And shout out to Mike Purcell. We're part of the Confidential Computing Consortium under Linux Foundation as well. And according to the Confidential Computing Consortium, confidential computing protects data and code in use by performing computation in a hardware-based, attested, trusted execution environment. There's a lot of interesting words there we're going to explore throughout the session. But in short, there are secure, isolated environments that prevent unauthorized access of modification of applications and data in use, thereby increasing the security assurance for organizations that manage sensitive or regulated data. How does it do that? So trusted execution environment, think about that as a fortress where your application, your data is encrypted, but the key is inside the CPU. And that has allows for many technical advantages. And your app and operating system and hypervisor and even operators handling the data aren't able to access the code and data in use within the CPU. So trusted execution environment provides security guarantees, code integrity, data confidentiality, and data integrity. It provides a remote attestation, which allows a remote party to establish trust with the programs running inside a trusted execution environment, and we'll talk a little bit about remote attestation in a bit. Performance, very small overhead for processing large amount of data, and portability. You can deploy the existing container virtual machine or program and support a lift and shift model where no modification is required. So it allows to protect your T from being read. And I was expecting as well that we wouldn't get the T joke, so I included this other meme that explains what the T joke, and instead of having T, I have a trusted execution environment. Anyway, tough crowd, guys, tough crowd. But anyway, remote attestation, how do we know the trusted execution environment can be indeed trusted? So the remote user is considering to put this their data into a trusted execution environment. And the trusted execution environment says, well, just trust me. And how do we do that? Well, we should verify how to trust that. And they produce an attestation, a proof that they are the hardware is that you're expecting, so the user is okay to send the data on their secure channel. Now, it's important to note that this operates on the assumption that we trust the TE hardware provider. And I'm going to mention that because I have a shameless plug for another project TikTok is working on, which is a trustless attestation verification project. Now, this is a little bit how remote attestation work. The software initial state produces a hash, which is signed by a private key. That hash and signature is sent then to be verified using a public key, confirming, therefore, that the code and the data inside the trusted execution environment are indeed the code and the data that was originally expected. And here's the shameless plug. As I promised, we have also a project working on a way to not rely on that hardware hardware assurance from the trusted execution environment hardware providers. Okay, now let's talk a little bit about private data analytics and also model evaluation. When we talk about that, people usually think, well, let's talk about value extraction, recommendation systems, machine learning, but there's also multiple public interest aspects of sharing private data. There's public health data, for instance, public safety, private information for associating crimes or illegal activities, education, academic performance, attendance, engagement, civic engagement, and any more. And for model evaluation, here are 4 benchmarks for fairness and bias detection that tries to make models more fair, and there are many, many more. And then we'll talk about that. Another shameless plug is that within our teams, we're producing also fairness assessment mechanisms. So InFelm is one of them that came out of our privacy teams and AI governance teams. So if you want, have a look at our blog for more information. But why is this hard? Why private data analytics is hard, model evaluation is hard? Well, in the old days, we had an organization which contained its data and its compute power, so they were accountable and transparent. They should be accountable and transparent for that. But nowadays, this looks a little bit more complicated and diffuse because organizations sometimes are collaborating with data warehouses, cloud providers, who manage other data and have different computing needs and so on and so forth. The second challenge is data privacy risks. So data providers may have conflict of interest. Data providers may not trust data consumers. Data providers may not trust the computer provider. On top of that, there are compliance challenges, which is privacy policies such as data retention or purpose limitation. Providing raw data might be legally prohibited. Changing the geolocation of data can be legally restricted, and so on and so forth. So what do we need? Well, I personally think that we need another reception like yesterday night. It was really, really nice. I've never been to a better reception than that one. But on top of that, I think we need a standard way that provides strong privacy protection mechanisms, privacy enhancing technologies that, while maximizing the utility of data. We need technical enforcement policies that go beyond terms and conditions and honor codes, proactive measures instead of reactive. We need accountability and transparency, auditability of the full system if necessary, and verifiability of the integrity of the results. And you'll see how this is important for the model evaluation demo that we're going to play in a second. And that I'll play in a second. And usability, provide accurate results that must, and it's important that it's easy to deploy and easy to use and easy to customize as well. So what are the existing approaches? I'm sure I'm speaking to the choir here, but just to make the point, we have SQL policy-based data clean room, which is rely on a third party to ensure that there is a mediation between those two data collaborators. And it's very accurate and very usable, however, it doesn't really respond to the PET and technical enforcement and transparency requirements that we need for this type of project. Differential privacy, which is a way of injecting noise into the data set and which allows to still have usability of the data but not identify a single point, is very usable, respond to the privacy-enhancing technologies and technical enforceability requirements, but for the exact reason of the technology, it's not transparent and it's not very accurate. The metaphor for this technology that I like is, I'm able to see the entire forest, but I'm not able to point a single tree with the injected noise on the data set. Finally, the trusted execution environment presents the PT, the technical enforcement and transparency requirements, and is very accurate, but usability could be better. And for this reason, we created ManaTEE, which is a confidential computing consortium project. We donated to the confidential computing consortium with the objective of benefiting from this open governance model and circulating, sharing with the community. So the goals with the projects is technical enforcement via privacy-enhancing technologies, make it usable, provide accurate results on real data as well as evidence of execution, which is very important for data collaboration, make the system transparent such that it can be audited and verified, and make it easy to deploy to the cloud. So this is a little bit the mapping of needs of different stages. So the programming stage, you have smaller data and computation needs. You can make it interactive, so you can develop the research questions or inquiries that you were working with the data set. It is harder to control the data set, however, and there are higher privacy risks, and therefore you should work on a synthetic or a differentially private data set or a sample of the data set. When it goes to the execution stage, it's larger data and computation power. Only one-time execution is really needed because you already checked that on the programming stage. And it's easier to control the data and it's lower privacy risk. So this is more or less how it looks. The user obtains, or the collaborator obtains the synthetic data or a sample size of the data on normal instances. They program their inquiries and process the data on a Jupyter Notebook, then passes to the execution stage where the actual data can be processed in a safely manner, and then the aggregated outputs are produced. The benefit of this two-stage execution model is that we separate data policy from code policy, flexible data policy on the programming stage, and the code policy enforced only at the execution stage. Accurate results in execution stage, full data access is securely enabled with confidential computing. And why confidential computing? We already know that. Provides transition of trust, making it work with various trust models, provides the integrity of the execution, and provides proof. So let's talk about quickly some use cases. The TikTok Research API, for instance, uses a fourth version of this technology. So public health, cultural trends, economic impact can be distilled from the platform through these inquiries. And we also have the virtual compute environment research tool, which is available for adoption for use in Europe. And we have other potential use cases like ads marketing, machine learning, finances, healthcare, and so on and so forth. And we're excited to see this tool go forth and prosper in those cases. So here are a few tutorials and demos. I put a QR code and a link if you want to follow on your phone or if you want to save it for later. But basically, the first demo is model training. So we're going to train a model based on a data set that we don't have access to. The data set is the insurance charge data set from Kaggle. The task is to train a model predicting the insurance charge and XG boost regression. And we're going to work with a private, differentially private synthetic data in the first stage. So let me see if this works. So just to show how the interface works, of course, it's not a trusted execution environment because it's not allowing me to. So we opened this on the Jupyter environment, and we push the data from working data. And then we can run some statistics, analytics. And then we submit a job to then run the regression. Are you able to read? And then download the output. And then that's already trained on the data of inside the data set. So the second demo, which is, I think, the most interesting for this session, is verifying an LLM model evaluation. So we're verifying the evaluation of the model, evaluating the model fairness and generating verifiable reports. For this, we use open source model DeepSeek and the LLM evaluation harness framework. And the evaluation tasks is these 4 benchmarks for bias, which I'm going to quickly talk about. Basically, LLM and evaluation harness acts as a diagnostic tool, kind of a dynamometer for language models like engines. It runs standard tests, but does not contain or own the model themselves. The LLM evaluation harness decouples the active evaluation from the model itself, and it contains a series of benchmarks inside. BBQ is a hand-built bias benchmark for question answering. So the core idea here is that we can test an AI model relies on harmful stereotypes to fill in the gaps when the question is intentionally vague. And this is the reference. Finally, challenge data set for measuring Crow-S pairs, a challenge data set for measuring social biases. The core idea here is to directly measure a model's preference for typical sentences over non-stereotypical ones. Simple co-occurrence bias. The core idea here is to measure immediate gut reaction gender bias by seeing a word a model predicts next in a sentence about an occupation, if it's what's that gender. It uses a basic sentence template and asks the model to complete it. The mechanism is to measure the probability the model assigns to masculine versus feminine words immediately following a word for a profession, and the reference as well for this model, for this benchmark. And finally, why no gender bias in coreference resolution. The core idea of this one is to test if gender stereotypes interfere with a model's basic grammatical understanding of who a pronoun refers to. So they intentionally put pronouns on like he, she, or they, and depending on the context and changing those pronouns, the model changes its answer, and that is what is analyzed about who the pronouns refers to. And that's the reference of the benchmark. And finally, verifying this LLM, verifiable LLM model, we're using the same framework, we're using ManaTEE framework. So the evaluator uses the programming stage to ask questions and test. And on the execution stage, the model owner or the evaluator, in this case, feeds into the data so that we ensure that the data there is, there's no tinkering with the data or changing mid-review. So Here again, submitting a task where we are going to install the LLM evaluation harness and choose the model to evaluate, submit the job. And then we will retrieve different benchmarks for each benchmarking each task that we are submitting. And then finally, we check the attestation report, which is produced through this key, and then we test. We verify. Oh, invalid signature. We verify if the attestation report is indeed true. All right, finalizing here. So the lessons learned is that confidential computing is a valuable tool not only for security but also for privacy and, as seen, transparency. Confidentiality is only one aspect of confidential computing. It also offers integrity, attestation, and transition of trust. And in the future with AI, trust will be as important as performance. As models become more powerful and sensitive, secure evaluation will be critical, not just as a technical need, but as a foundation for AI governance. And of course, ManaTEE enables that verifiable AI model evaluation using confidential computing. What's the current status of the project and what is the future? We're currently we have one-way collaboration, and we want to create a multi-way collaboration. The backend is still single backend, and in the future we hope to have multiple backend. Data provisioning is still manual, and in the future we hope to have it automated. Policy and attestation is the same, and compute today is only on the CPU, and in the future we want to have CPU and GPU as well. The first community release is for open collaboration, so also again the link for the GitHub if you want to bookmark it to see all the technical documentation and also be in touch. And if there's any questions, I can take them now. Thank you very much.
You say multiple backend. What do you mean by that? Do you mean different silicon vendors or something different?
We're trying to understand if there could be multiple multiple vendors, but also multiple. Sometimes in having multiple users and collaborations will require different data points as well. So the question was, if I understood correctly, if the API of the confidential computing is standardized or if every vendor is the same, and the answer, Mike, is that it's...
They're different.
They're different, yeah.
And so ManaTEE
Do you know this question, Mike?
I don't know what ManaTEE supports natively.
I think natively is GCP, but you can alter it. You can customize it.
Okay, but default.
Yeah, it's default.
Use it with GCP.
Exactly.
Okay.
Yeah.
Okay. Cool. Thank you very much.
Thank you.